yesterday we learned about value depreciation, or about decay, or about money getting less worth, which is constantly happening to us in South Africa. First question said, he's got a printer, I can't remember what thing it was, but they said, what will it be worth after 5 years if it was a depreciation rate of 20%? So there was nothing unclear about that. They said depreciation rate. So depreciation immediately means that you've got a formula with a minus in it, right? So something was plotting over here and you're thinking it's wrong. Question said there was a depreciation rate, that's what's negative, over 5 years. Now, before I even do the question, should this be less or should this be more? Less. Because I'm taking this and making it depreciate so that the accumulated amount or the end amount will be less than the starting amount. And what was it, please? 2621.
4,4.
Right, always with money. Second question said, if I take a printer, I think it was, that was worth 8,000 Rand, they would like to know, the words were very accurate there and you had to listen to the words. They wanted to know what this printer would be worth after 3 years if there was a 6.5 rate of inflation. Now inflation means that in 3 years' time this thing is going to be more. Are you with me? So I called you out and that's exactly what's going to happen in a test. If you've got the plus there, you don't get the mark. If you've got the minus there, you don't get the mark. If you've got the plus there, you do get the marks. They never said use compound interest or balance, increased balance method or decreased balance method. They didn't say that. They just said there is inflation. Inflation means that the amount is going up. It used to be 8,000, now it's going to be worth more, which is
9,630,60.
Come guys, work with me here. Alright, the next one said about a calculator, this was in 2017, they said there in the question. The calculator was worth or cost me 150 Rand. In the January 2017. In January 2019, that same calculator, well I hope it was a little bit better, was worth 220. That's definitely not the case in this current era. Our calculators in 2023 at the moment is about 600-700 Rand. Okay, so from 150 it went up to that. So this was an increase. The question also said, for this to happen, what does the interest rate or the inflation rate have to be? Again, inflation rate, meaning it's got to be plus. This cannot be less and this more if that's not a plus. If this is more and this is less, then that's got to be a minus, and it's got to make sense to you. Alright, so I'm looking for the rate and I'm giving you 2 years. The 2 years wasn't given either. They said January 2017, January 2019. You had to estimate and say that, okay, that's 2 years. Maybe you made a mistake and you said 3 years. No more marks. Now you lose 1 for not saying it's 2 but saying it's 3. And then your answer wouldn't be the same as mine, but you could still get the marks for doing the correct calculation because that's correct math. Okay, please give me the interest rate there, 0,
21106,014.
Okay, that's enough for me to say if I time with 100, it's 21,11. The inflation rate is 21,11. And with that, we are done with financial maths. Quick. How many marks in an exam? Full exam? About 10, 12 marks. Roundabout. What do I ask? It's going to be either, okay, it's just compound at the moment on the board. Either going to be compound interest, either decay, or it's going to be growth. Or in other words, interest rate going up, or regression, or what's the other word for decay? Depreciation. Just help me. Depreciation. But if it was a plus, then it would be appreciation. if it was the simple interest, you've got to look for the correct place to use that as well. So both of those formulas simple interest, compound interest can either be used with a plus
or minus.
or with a, and you have to know which one to use when. Then we also did this year only with compound interest. We also did that it's monthly and it's annual, semi-annually and it's quarterly, etc. That you had to work out that those two go hand in hand. And then we did the timelines, and that's it. No, that's not quite it. What about effective and nominal? And all of that has to be done in about 12 marks. So not everything always gets tested, that you should know. All right, that's it. So our next piece of work is number patterns. Now number patterns, when you get to grade 12 and you're doing your final exam, you're going to know just like you know now. At this very moment, you only know grade 10, which you learned in grade 8 and 9 already, was the linear number patterns. And the linear number patterns had a general formula which was? And now some people use the C there, doesn't matter. This still represents as a graph. What type of a graph?
Linear.
A straight line. Look at it. A, n plus b. The n is unknown, right? But the a and the b are numbers. So doesn't that simulate, which is a straight line? Are you with me here? That's why it's linear. Nothing that I'm saying at the moment is new. It's the same thing as you've learned for 3 years. So first of all, the question might have said, what are the next two terms? And your answer would be? 13 and 16. How would you do that? Because you were taught in grade 8 and 9 and 10, you go and get the constant difference. Now I'm going to start calling it the constant first difference. Constant difference which you got on which way? Listen carefully. Second term minus the first one. 4 minus 1 is 3. 7 minus 4 is 3. 10 minus 7 is 3. It sounds so silly. But when you get to negatives, you're going to shoot yourself in the foot. Please from the start always say second minus the first, third minus the second, fourth minus the third. Because when you get to the negatives, and we're going to be working with x's sometime as well, you've got to know that, which I'm teaching you there. Fact of it is, there's a first difference that is constant, and that's what makes it linear. So then my second question would have been in grade 10. Please find me the general rule for the pattern, or the general term, which then would be Tn. So if I start off, I'd say Tn is, and what is that 3? It represents the A. Knowing that is your first mark. That 3, the constant first difference, is the worth of A, the value of A. Then how do we find B? What were you taught? Substitute? Anyone, you're quite right. But the logical one would be to substitute n with 1. Alright? So if you substitute n with 1, what does n represent again? The position. So this is term 1, term 2, term 3, position 1, 2, 3. So for position 1, this answer should be 1. If you really wanted to put a 2 in there, that's fine. But your answer then, if it was 2, should have been equal to 4. But because you chose term 1, it's not because of that one, the answer is equal to 1. If you chose a 2, it would have been equal to 4. If you chose a 3, 7. Are you with me? And with all of them, your B value would have worked out too. 3 taken across is minus 3, so the answer is negative 2. So that my general rule would be 3n minus 2. General rule for a linear number pattern. How do I know I'm right?
You substitute.
Test by substitution. Now I think we've just done that 1, so but that should be fine. 3 times 1 is 3 minus 1, 2 is 1. If it's the second term, 3 times 2 is 6 minus 1 is, okay, 3 times 3, yes, it's 7, I think we've done enough, but you can always go check yourself. So then what was the third type of a question that you could always get asked? Find me term whatever I like, so please, you don't go sit there and say, if I add 3, if I add 3, if I add 3, if I add 3. That's the reason why we're looking for patterns, so that we can make deductions from it. Now that I have a general term, I can do all sorts of things with it. So if I want the 77th term, I need to say 3 times 77. Good news, if you mess this up, although this is very level 1, if you mess this up, you can still get marks. Because if yours was like 4n minus 8, and you take the 4n minus 8, substitute the 77 in and get the right answer, you can get those marks. Because you did the right math. You took whatever your rule was, substituted it in, and you're getting an answer of 299.
No, 2299. 229.
Guys, just say it once. 229. Okay, why am I struggling with you today? With number D, another question. I will ask you, which term will be equal to okay, now man has to just check, and I hope I checked it correctly in my mind just now, because I can't just put any number there. I've got to make sure that it's one of the values that will be in this pattern. Otherwise it's not going to work. So let's check. So if I ask you which of the terms will be equal to 64, what do I do? So I want to know which term will be equal to 64, and the term formula is? Okay, so the difference is, there you substituted the n in. This time you took the whole formula and substituted it equal to the term number, or the term value. Now to get the answer, normal linear equation, which will be 66, and if I divide by 3, if I made a mistake now when I was thinking about it, and I made this 65, this would become 21 and a half or something like that. How do I know that's wrong? I'm asking you which of these terms. A term number can only be, like in athletics, position number 1, 2, 3. You don't come 3 and a third in a race. You also don't get 0th position or minus 3 position. Okay? So it can only ever be a natural number, which means 1, 2, 3, 4, 5. Not even a whole number, because whole numbers start with 0, and there can't be a 0 position. Can't be -2, so it can't be integers, just by the for the sake of being accurate. And that was grade 8 and 9 and 10 you were tested like that. Today we're starting with quadratic number patterns. So when we get to quadratic number patterns, now think about it, remember everything in math comes back to patterns, and patterns come back to graphs. So we already had the linear pattern which comes back to straight lines. Now we're going to have a quadratic pattern that comes down to parabolas, right? You see the parabola? Ax squared plus bx plus c is equal to y is a parabola. Are you with me? So when you sketch it, it's going to look like a parabola, but with some restrictions. Okay, I'm not going to get into the restrictions now, but you can't do parabola like that, because this doesn't make sense. Because if this is your n and this is your tn, n cannot be -1 or -2, etc. So that wouldn't make any sense. You with me with restrictions, but it's still a quadratic pattern. Just keep it in mind for future reference. So first of all, you would have thought, aha, number patterns, let's go for it. First, difference. And the differences are, please tell me what I'm saying. 5, take away 1 is 4. 12 minus 5.
6. 2. 13.
Are you with me? And it's not the same. So now, if the first difference is not the same, because that's all that can happen in 2 weeks' time when you're writing the November exam. It can only be linear, like I've just showed you, or it has to be quadratic. Now, if it's not first difference, then you look for a second difference. So then look for the second difference. How are you going to do that again? 7 minus 4. And if the second difference is the same, then it's quadratic. Because it might not be, because there's other stuff you still need to do next year. You're going to do exponential or geometric patterns. So after doing this, and it doesn't work, there's another way to go, another pathway to go. And is that all the number patterns that can possibly happen in your life? Okay, let me make an example. I'm sure I did it once or twice with you guys already. If I tell you, please tell me what is the next. What is the next number in that pattern? Is there a pattern?
Yes.
What type of pattern?
It's just a pattern.
I don't know what pattern. Can you see a pattern?
Yeah.
What will be the next one?
1, 0, 0, 0, 1.
Now, I will not ask you for the general term because there isn't one. But there's a pattern. Are you with me? Or even in grade 8, you had maybe. And I asked you for the general term. And then you thought, oh, okay, what's happening there? What are those numbers? Yes, excellent. They are the square numbers, which you're supposed to recognize. So what is the general term?
In square.
Fantastic. So what about the cube numbers? But we're not doing cubic. Square is fine. We're doing square. We're doing quadratic. But this is not our syllabus. Can I ask you something like that?
Yes.
Yep. A little bit out of your comfort zone, but you can figure it out. Are you with me? So there can be something else happening. And there are something else happening next year. There will be something else happening, except for just linear and quadratic. So just know that if I ask you something like that in matric paper, it's not out of the syllabus, but I'll not ask you for the general term, I'll ask you for the next term. And that's fine, no problem. Or maybe even for the sum of the first 5 terms. What is the sum of the first 5? Add them together. You with me? 1 mark, 2 marks, easy peasy. Okay, just getting your mind into there's not only one thing. Alright, now here comes the nice stuff, because quadratic number patterns has got a recipe. You like recipes because you can study them and you can always get them right. So the way that they work is, there are 3 formulas that you must know off by heart. And the 3 formulas are 2a, let me do it here. 2a,
3A.
and I'm not going to show you where it comes from. You can really go and do some investigation and find out where they come from. If you know them, you can do the sum. What's going on here? Okay. So how I'll teach it to you is the following. Those 3 formulas are going to be used in the following technique. You're going to say 2a is equal to whatever's standing over there. That number there, which is going to be the second difference. That's going to be your step number 1. You're going to put that 2a equal to 3, and what's going to happen here? You're going to find a. Are you with me? Then you're going to go to step number 2, and you're going to use 3a plus b and put it equal to whatever there is. Not the 7 and the 10, whatever the first one in the second row is. Then your third step would be a plus b plus c. The formula put equal to whatever that first number in your whole pattern was. It's a formula, it's a recipe. So the steps are 1, 2, 3. First step is you take the 2a. I'm not going to explain to you where they come from. You can go and have a look. It is explained in your textbook. It takes too long time. Afterwards, you just know that you've got to learn from your head 2a, 3a plus b, a plus b plus c. Kids get confused. They want to make the 2a, the 3a, and this they never get wrong. A plus b plus c. But they are the steps. Step 1, whatever's there, 3a plus b. The step 2 equal to whatever's the first one there. A plus b plus c equal to the 1. So I write here, 2a is equal to 3, and I do the sum. the sum is going to be A is equal to 3 over 2. Are you with me? What is this A I'm talking about? We're searching for A and N squared plus B N plus C. That A and B and N is what I'm solving here. Alright, it's a pattern, a recipe, always. So in step number 2, I'll take the 3A plus B and I'll put it equal to. But now I have some more work to do. I can substitute the A with a,
3 over 2.
and then I'll get
Calculator, guys.
a calculator. Excellent. Right, with a calculator you'll find out the value of B. And once you have A and you have now B, then A plus B plus C equal to 1. Your A will be 3 over 2, your B negative a half, and your C. So that when you add it up, this is going to be 1 minus 1, so C will be equal to 0. Now 0 is not a problem. What does 0 mean if I'm drawing a parabola? C, 0 means that it's the y-intercept, right? Can B be 0 in a parabola? What did B do if it was 0? That's grade 10 parabolas. That's when they were always symmetrical around the y-axis. But can A be 0? Then it's not a quadratic formula anymore. If A is gone, the quadraticness is gone, the parabola is gone. So A cannot be 0, but both of them, the B and the C can. What was my question? Please find me the
So, A, B, and C.
general. So you got to know that it is A n squared plus B n plus C, and then just substitute. So what it's going to be 3 over 2 n squared minus a half n plus 0. You can write plus 0 if you want, or you can leave it away. It's no problem. Can I test this?
Yes.
It's tricky, haha, because it's all these fractions, but you can test yourself. And you won't test all of them. If you substitute with 1, you're going to get 1. If you substitute in with 2 and you square it and you time it and you time it there and add them together, you will get 5. And once you've done 2 of them, you're quite happy with it. Can you now also get the term 77?
Yes.
By just substituting in with 77, calculator is a wonderful thing. Can I ask you for which value is equal to whatever? I can work out one, so I don't know which one to take it to. Are you with me here? Because I'm going to give you 2 like these for homework. Just to find the general term. Okay. Okay, so your homework sums are number 3 and 4 of number C on page 44. Exactly the same type of thing.